Okay, hi. So today I'm gonna explain this one game I made. It's Flappy Bird. We've all played Flappy Bird. We know what it is. I just recorded the very same video like 5 minutes ago, but turns out my mic wasn't on. So I'm just gonna zoom past this. Anyway, I'll just play the game and show you how it works. Mm, okay, yeah. So you can see the physics of the game is actually quite accurate. You can see my guy cannot go past this, and he just falls down. Anyway. So the very first thing I did is create a game object called bird because obviously we need the bird. I put a sprite on it, which is this image of the bird, and I put rigid 2D and circle collider, which basically allows it to collide and like interact with the laws of physics. After that, I put bird script, which is actually a code for the bird. So I'll just go over that. Oh, and by the way, Unity connects directly through VS Code. So you just write your code here. Anyway, first things first, I made a reference which connects this code to rigid body 2D. Basically, it allows this code to alter the physics of the bird. Now, we have void start on line 10 and void update on line 16. So, void start is a code that runs in the starting of like the program, and void update is a code that runs on every frame of the program. The bird code is very simple. If space bar is pressed, then the bird's velocity in the upwards direction increases. You can see I have vector up, so that just means that j cap, it's a unit vector j cap, I j cap, I mean 1 j cap, multiplied by 20 to increase its magnitude. So 20 j cap is how much the vector, like how much the velocity of the bird increases just by me pressing spacebar. Now obviously we need pipes, so you can see I have pipe spawner, a game object here. Now the very first thing you can see in pipe spawner is we have another game object inside it called a pipe or an individual pipe which uses this pipe move as its code. Now in pipe move you can see I've made two references to the move speed and the dead zone. You will see what I mean by that. Now in void update you can see that if my pipe position is less than a dead zone, then it destroys the pipe. So basically in my game over here, if this is my bird, does anything after this point matter? No, because it's going to be out of my frame. So I can destroy everything to the left of that point, which is what I have done. And then to move the pipes, I have used this code which basically moves it to the left. So instead of moving the bird to the right, I move all the pipes to the left. I don't know why I did this. I couldn't think straight, but I did. And as you can see, I've used delta time here. Delta time ensures that your timer actually does not matter on the FPS of a computer. Since over here you can see that this code runs on each frame, of course your FPS will matter because that determines how much the code runs. So since I've used this time.delta time, it actually divides the FPS by the FPS again. So there is no unit, and then there's no variation between computers due to this. Now you can see in pipe spawner we use pipe spawn as a script. So I'll just open that up. Now pipe spawn, the very first thing is it calls game object pipe. So it calls this pipe move script, and it references three other variables: spawn rate, timer, and offset. And we see that. Now in void start I have spawn pipe, so it just spawns the pipe. You can see the function is given below. And in void update I have this code. This code basically tells me if the timer is greater than my spawn rate, then I have to spawn a pipe, and then my timer becomes 0 again. And then since my timer is less than my spawn rate, it will gradually increase on every frame until it becomes greater than my spawn rate. Again spawn the pipe, again becomes 0. But now how will it spawn a pipe? Here I have two variables which basically are the position of the pipe plus minus a certain limit, which is the height of it, which I have set over here. So basically I have used instantiate which creates a new pipe. Since pipe is written here, it's the object to be created. And the position for the new pipe is same x position as the old pipe. For the y position, it is a random number between the lowest point possible and the highest point possible. So I have basically created the old pipe I have taken as an average, and then I'm taking variation of 10. And then z, since we're